All right, welcome back. We are COMP301 in the summer 2020 semester, and that's Linux operating system at Centennial, and it's week 8, part 1 of our broadcast. We're still working on Python. Last week we did a crazy overview on Python. We covered all kinds of stuff, everything from classes to functions to overloaded operators to a bunch of stuff, right? And I wanted to give you kind of a really broad overview of, how much power Python has. Again, I would say Python is one of those languages that is easy to learn, hard to master. It's one of those. It's like a video game. Easy to learn, hard to master. You can learn it easy because it reminds you of structures in other languages. Hard to master because there's a ton of things you can do in Python, little shortcuts that you can do in Python that, trying to remember them all is really, really hard. So you have to kind of practice on the Python side. I have a little PowerPoint that I'm going to be using today for today's presentation. Again, just from a schedule perspective, I wanted to bring us up to date where we are. We're sitting at week 8. There will be a quiz this week. I won't bring it into play until probably Thursday, just to give you a couple of days to do it. Again, it won't be that challenging, but it'll be based on everything from last week and today. So straightforward, probably 10 questions on the stuff that you're doing. So I'm going to release it on, is it quiz 4? Or maybe quiz 5 on Thursday, and I'm also going to release an assignment on Thursday as well. This is when I'm going to do that. The assignment, you have enough now with the stuff that I talked about last week and the stuff I'm going to talk about today to get it done. Last week, if I gave it to you, you wouldn't have been able to get it done or even start it properly. So this week, I think I feel more confident with that. Things I'm going to cover this week. Today, I'm going to go all the way down to probably around right here. Pack tuples and unpack values with a tuple, tuples, and random numbers. The rest I'm going to cover in a second PowerPoint on Thursday. So that's what's happening with this stuff. But really, what I really want to cover more in depth is functions. The function is kind of like, I would say, the base component of everything that we do in Python, more so than even classes. I mean, when you do data science, my machine learning professor, when I was doing it, he said, Tom, I never use classes in machine learning or data science. And I'm like, really? And then I realized why. Because it's like a big algorithm that you're running. One big algorithm, one big file. You run it, and it does all the stuff for you. You certainly can use classes and to make your life a little easier. I like to use them. But a lot of guys that I've known, a lot of professors and other kinds of data scientists or whatever, they don't use classes so often, more than methods or functions in a row, really, one function after the other function, more functional programming as opposed to object-oriented programming. So a different way of thinking in Python, and again, that's what makes it more challenging in some ways. Once you start going with it, you realize that you don't know so much. You think you know a lot, and then you're running with it, and you're like, wait, but I can do it this way, and this way, and this way, in 10 different ways. Wait, that was a bad way of doing it, and I should optimize this way. So we're going to talk about a few things as we go. So first, we're going to start defining custom functions. We've talked about custom functions, but here's an example of a custom function that I'm going to write. So again, I'm going to go into Visual Studio Code here in Ubuntu, and it's going to run when it decides to run. Here, with my system being bogged down with a bunch of stuff that's going on. There we go. It's going to try and open the last thing I used. So typically, VS Code, doesn't matter the platform, it tries to open up something that I've done before. So this is all the stuff, the craziness that we did last week. I'm going to move away from this craziness. That's what I want to do. I think this is a good thing. And we'll start anew. So we'll start a new lesson 8, part 1, with a bunch of little examples just like this. We'll start with a main, and we'll go from there. So again, file. I'm going to close my folder. And I'll do things all in Visual Studio today, if I can, use VS Code. I'm going to say open a folder. it's going to point me to the desktop where I'm going to create a new folder, this little plus right here. I'm going to call this folder COMP301 M2020 lesson 8 part 1. There's going to be more than one part, I think, this week, but we'll see. So that's the folder I'm going to use, yay. And all I'm going to have in here again is a new file called main.py, which is going to be empty right now. Okay. I'm also going to put this up on GitHub immediately, so control backtick, right? I'm going to go back to the terminal one day. Come on. Come on. And I'm going to say git init in here, git add dot, git commit -m, initial commit. So this is when I kind of made my local repository here, and now what I want to do is I even use Chrome from in here to do it. Why not? And I'll push this up on GitHub too. Restore pages from a shutdown. Nah. Centennial. You can see there's a bit of a lag when it comes to doing this stuff. I'm going to make a new repository here. Make sure it's public. And COMP301 and the summer 2020 semester, and it's lesson 8. Part 1. Sure, we'll try part 1. I don't know if we'll get to part 2, but I'll try. So again, open up a new repository. I have this code. Now it's not so easy as it is in Windows to do this, but you can copy paste. So I'll copy this one. So Control C or copy. And if I go back to code, I can paste it and press enter. And then I can go back to this, just to be lazy, copy, and then paste and enter. So it kind of does that. It'll put it up on GitHub, all that regular stuff that we normally did. Now we have a base of an empty file on GitHub. And if you look back, if I refresh GitHub now, you have this. And inside here, inside of eCentennial, I'll make a new link. Create a link. So we'll say GitHub link for week 8, part 1. And I'll add that in on the Windows side. Beautiful thing about using GitHub is it's so cross-platform. I mean, it's really easy to get kind of a hang of, and to go from one platform to the other. You know, it's super easy. So I kind of like it from that perspective. Sometimes though, when you're merging, I think the biggest challenge with GitHub is when you're merging, when you're using, you're kind of collaborating with somebody else. That's where GitHub can be challenging when you're on collaboration. I don't think it's challenging to use it, to push it, and to create stuff with it. I think it's great. It's just collaboration stuff. Okay, so really what I want to do today is focus on this idea of functions, right? So here we made a function called square, and one of the things that it talks about in there's a Python reference, and from a convention perspective, it says, hey, what you should do is you should create this little docstring, is what this is called, on the second line of a function. Every time you make a function, convention says you make a docstring, and the docstring itself would give you code hinting when you use this Python function later on. Okay, so in Visual Studio for JavaScript, the docstring, or comments, would be above the function. Here it's inside the function. Let's do that. So we'll make a def. We'll define a new function called square, and square will take a number as an example and square it, return the square of the number. Oops, that's the wrong one. It'll return the square of the number. So take a number and then return the square of the number. So whatever the number is to the power of 2. But we need to do this, calculate the square of the number as a docstring first. Okay, so that's what we want to do. So again, whenever we end a function, we use a colon for this. So colon, def square colon, and then the body of the function, we start off with the doc string. So // By the way, did you notice that? // and says generate doc string in Visual Studio. And yeah, I definitely want to do the summary. I want to say something like in the doc string, you can say something like, and you don't want summary in here. The summary is just, but you want to put in something that describes the function. So again, just like it says, we want to pass in a number. And what this will do is it returns the square of the number parameter, right? Parameter. There we go. And then that's what it does. We'll return number. Remember what happens for squaring, or to the power of 2. That's what it does. It takes number and to the power of 2 and returns that as an object, right? That's what it does. Cool. So we have our square function. That's what it is. And what I want to do with it is I want to try it out and print it out. So let's do further down. I want to use square. So I want to say, hey, I want you to square something. So print a string version of the square of 5. Okay, so that's what I want to do. And if I was to run this thing, so if I said, Python and then main.py, then we should get 25, right? Because what's happened is, and the reason why I have to use string is if I didn't use string, if I didn't stringify it, and I just used square 5 like this, so I take the square 5 and then I try and output that. A lot of times what happens is when I do this, because 5 is not a string, sometimes you have to convert it. And where it really comes into place is if I do something like this, square of 5, and then I want to do something like this plus stuff, plus square. It's going to give me an error because it's going to say, hey, I don't know that square 5 is not an int, so I need to do kind of a string of the square if I'm going to interpolate that way. Okay, if I'm going to do it this way. Again, we don't have to do it this way. We can use interpolation. There we go. A little bit nicer. There we go. Square of 5 is 25. Makes sense? So that's really the way we use a function. But we also have to think about this function here. If I print out the function, so square, not the call, I'm not calling the function, I want to print it out, right? Then I'm going to get this function at a specific address. And keep this in mind that this is actually an object that we're making. Everything is an object in Python. Everything but everything, right? So keep that in mind that as we're progressing. So again, to make it, we have to use a def keyword, which is we're defining the function. We don't use any function keyword. We use the name of the function, square. We pass in any parameters. You notice that there is no data type that we have to specify here. We don't do that in Python. However, when you hover over, it says that the square returns any, right? That's what it returns. The dash greater than sign is a return. That's what it does. And if you hover over, it also tells you the doc string. So it returns the square of the number parameter, just like we would if we were using JavaScript, or if you use the // in C#. It does kind of the same thing. It creates this documentation for you when you do this kind of stuff. Okay. So kind of interesting in terms of how this works. And if you step forward with this little PowerPoint that I have in here, it talks about type error. So type error, if I was to pass in something else in there, so let's say, for example, I passed in, instead of 5, which is a kind of a hard-coded value, I passed in hello. Then when I try to do this, you get a type error, unsupported operand types for ** or power, right? because string and int are not compatible. You can't take hello the way we've written our square function and square it. Can't do it, right? We might think of an interesting way of doing that. I mean, taking in a function that takes a string, and then take each of the characters of the string, convert them into numeric values, ASCII values, square those, do some kind of operation with them or something, and then return them, return a new string. That'd be interesting. Weird, but interesting. But that is something that we can't do by now. Right now, we can't take a look at hello and do anything mathematically with it that's anything close to squaring. All right, so that's why it would return a type error. So even though Python, as a reminder, is loosely typed, so we type it when we assign it, right? There is no let or const or anything like that. I don't have to do that. If I say something like, square of 5, right, is equal to square. Let's cut this out and fix it up. Square, and we'll pass in 5, right? Square of 5, right? You can see now square of 5 is a type alias. Square of 5 is square of 5, and then if I pass in square of 5, square of 5, right, like that, it'll give us the same kind of output as we had before. Now this is interesting. So square prints out as something. What does square of 5 print out? Print square of 5. I'm just curious to see what it does. So remember that it gives us some kind of function. So there's square of 5 is 25. Function square of this. But then when we print square of 5, even though it looks to be pointing at it, that's one thing. What about if I said that square of 5, right, further down, let's say down here, I said square of 5 is equal to square. What happens then? Like, square is a function, I'm pointing to it with square of 5. What does it actually return now? Can I do that? And yeah, it kind of points to the same address, right? It's almost like if I want to make a reference to square, which is a function, right? So square is a function, and I want to make a reference to it. So square of 5 is now square. Then could I just do something that looks like this, square of 5, and I want to pass in, so this is square of 5, but now instead of passing in square of 5, I was passing 5. And does this do the same thing? Can I say square of 5, 5 as opposed to square 5, and would that do the same thing? You're going to say, why are you doing this, Tom? Why are you trying to confuse us? I'm not trying to confuse you. I'm just trying to say that when we make this kind of relationship, it's different than we do when we make this kind of relationship. This points to the value of square of 5, right? This points to the reference of the function square. Okay, just keep that in mind. They're totally different the way it works. And so when I output square of 5 earlier, if I try to do that, it would output the value of square of 5, which is 25. But if I do it here, it outputs the reference. And since it does that, I can use square of 5 as an alias to pass in a reference to another, like as if it's the function itself. So keep that in mind. That means that I can also pass functions as arguments to other functions, right? I can do that. I can pass a function, like a callback function, to another function as an argument. Okay, so just keep that in mind. All right. So we talked about how to define a custom function, and we've kind of done that. There's something called the functions block, and there's a control statement suite. So there's two different pieces to it. A control statement is, again, if, else, that kind of stuff. It's a control statement suite is what it's called in Python, and a functions block. Okay, two different things. We also talked about multi-line doc strings, that we can use them. They come in handy, and it kind of goes through the function and tries to get you to understand what it is. And so here, square of 7, we kind of did that example with 5. And then it talks about the idea of local variables. Okay, so let us define a maximum function. Okay, so maximum function, if I was going to define the maximum function between different values, right? So I have value 1, value 2, value 3. I want to find the maximum function. Here it says if value 1, if maximum value, by the way, it starts off with as value 1, and then we compare value 1 to the others, or maximum value to the others, and then we return whatever's left. We compare each one of them, right? So it's kind of a weird way of doing it. Let's do it here. And let's do it by making our own maximum function. So again, like we did before, remember how this is done. I want to make a new file. I want to call this function maximum. Okay, there's maximum. And inside my maximum, I want to define a function called maximum, which can take, let's say, 3 parameters. So value 1, value 2, value 3. We want to make a doc string, right? Which allows us to do this. Isn't that neat? With values, we can talk about what the types are. So where the type is numbers, right? So we say the first type is an int, but we can also specify that there is no type. It can take any. Let's say if we want integer values, right? And we can describe these values, value 1, value 2, value 3, if we want to. So this is kind of a short description if I want, or not. I'm not going to describe what those are. Those are arguments. This is my summary. I'm going to replace the square brackets with the summary. This function takes 3 integer arguments and returns the the largest value, the highest value. Okay, so it does really maximum. So remember how we can do this. We can say that just like we did before, if we're going to make this little argument or this little algorithm, we're going to say that max value. And again, I like to put max value like this inside of as a parameter name or a local local variable name. Inside a parameter list, if I had something like max value, that's where I would put an underscore for me. That's my coding style. Okay, so max value is equal to value 1. So you set max value as value 1 first, and then you compare. You can say that if, no brackets for Python, if max value, so if value 2 is greater than max value, then max value is equal to value 2, right? And then you compare if value 3 is greater than max value, then max value is equal to value 3. Okay, so that's that. And then we want to return at the end, return max value. Okay, so that's how that works. Simple enough, simple algorithm, and it checks each value with the other values, and then if it's found, let's say for example max value, if value 1 is 10, and then the next one is 11, and the last one is 5, 10, 11, and 5. So if max value is value 1, it becomes 10. If value 2 is greater than max value, so it's 11 is greater than 10, it's true. That means that max value is now 11. If value 3 is greater than max value, value 3 is 5. Is it greater than 11? No. So we just return max value, which is 11. So that's how it would work. Right, so kind of a simple maximum function. And I want to use this maximum function. Let's make it so that it's maximum with a capital M, just to make it different. Maximum, right? And then I want to use it in my main. So I want to go in here, and at the top I want to import. So from maximum, import maximum, as M. You can totally do this like a little thing. Actually, you can say as max, right? And this would hide the default max that's built into you know, this thing, right? So I can say something like, I have a list. We'll call this a list of values. Let's say we'll call this values. So we'll say the values are, like we said, 10, 11, and 5, right? There are the three values. And I'm going to pass in values to the max function. So I'm going to say result is equal to max of values 0, values 1, and values 2. Okay, so I can do this for sure. Okay, there's the result, whatever the result is. Result looks like an int. It detected that was the case. And then let's print out results. So we'll say print the maximum value is, and then let's use proper interpolation. So we'll say max value or results. Okay. And we'll use the F in front of that. That's the right way to do it. So maximum value is whatever the result is. And let's see what happens when we do a Python main. So max value is 11, right? So it kind of worked, right? We said that, hey, we have from maximum, which is the module, maximum.py, import maximum, maximum being the function name, maximum with a capital M, right? As max. Max is the alias, the local alias that it's going to be known as. It got defined as max here locally, right? And then, so now we can say that result is equal to max, value 0, values 1, values 2, and that is a way of doing that. Okay? Are we good? I did it slightly different than in the PowerPoint, and that's on purpose, so that way it can get you guys to try different things out. What if we wanted to take this square and do the same thing? I want to get all my functions out of here, so I want to put this square in its own function. Can I do that? Again, this is just review from last week, so again, we'll make this thing called square.py, right? And we can lift square out of main. So we'll say we'll take square out, take it out of main, and we'll put it back into square here. So there's square, right? And then what we can do is in main, we can import. I like to do the imports in this right order that I use them. So from square, and I'm going to import square. See, square can actually be the same case, right, as square, right? And so what we can do is we can say that this is square of 5, square, square of 5, square. I'm just going through it and changing everything that it has to be, save, and if I go back, you can see now it's still should run. Well, so what didn't happen? So it says input error, cannot import name square from square, right? So square, yeah, there's always I find there's always a weird kind of thing happening with the naming conventions, so making different names is a good thing. Let's try that out and try this and see if it's good. Yeah, we're good. Right, so maximum value, here's a square, and it also goes. So we can do this kind of stuff nicely, and I think that's why they do the things they want. But that keyword, from square, import square, from my file, import my function as a short version of my function, that kind of pattern, you're going to see all through Python and data science. Yes, we're going to be using Python libraries. I'm going to try and get you to use NumPy, matplotlib. We're going to talk about that a little bit, how to use that, you know, some basic functions, and again, trying to get you guys towards, you know, using Python for what it's supposed to be used these days, which is data science and machine learning, right? So when you take your machine learning course, you've done a little bit of Python and you know how to use some of the functions. It'll remind you of how things are done, and you'll learn more about it when you do your machine learning course, if you end up doing it or not. Yeah, so slowly, give me a chance. We're going to ramp up. Again, like I talked about this is easy to learn, hard to master stuff. Okay, it's not the other way around. JavaScript is like hard to learn, hard to master. That's JavaScript. You know, C# is easy to learn, you know, middle is still easy. At the end is still easy. At the, you know, when you start doing more advanced stuff with you know, hyper-threading and all that kind of stuff, and concurrency and a bunch of other stuff with C#, then it becomes hard. But C# is probably the easiest of them all, I would say, compared to all these things. And then Java, I would say, is harder than C#. That's why I prefer C#. If I'm going to code like from a utility language to work with, if you can work with any language, C# is good. If you're going to do something that's lower level than this, then it's going to be C++. And if you're going to do data science, Python all the way. I don't think I would do anything but Python. Maybe C++, because sometimes C++ has some of the same functionality as Python, and it's very much more generic. You know, so you can do more things with C++. You know, especially if it's more complex. But Python, you can get away with a lot, and there's a lot of libraries already written. Do most banks use Python also? For machine learning, yeah. Yeah. I would say so. I think JavaScript is definitely hard because, you know, there's so much to learn with JavaScript. JavaScript is a very well-defined language. It's been around for a long, long time. It continues to evolve and grow. Python is the same. I mean, Python's got a couple of iterations. The first iteration was Python 2. I would say I worked with Python 2 extensively, and then there was flaws in Python 2. They really fixed up the language to go from Python 2 to Python 3. Python 2 and Python 3 were completely not backwards compatible. There were breaking changes, so one language couldn't really work in another language. And unfortunately, I have to tell you this too, a lot of machine learning stuff is also still in Python 2. So you have to take Python 2 with a grain of salt, convert it to Python 3, and it's, you know, there's stuff like that happens out there too. But so when you get into machine learning and stuff, you're going to see that there's still some things with Python, you know, that you have to worry about. But I mean, take a look at this, man. I mean, literally, I'm using modules with Python, and it's like 2 lines, right? JavaScript, whoo, man, you got to jump through hoops to use modules properly, right? But here in Python, we're good to go. So it's really super easy, and that's why a lot of times people like to use Python for backends, like things like Django and stuff like that, where they can write a Python server, and it's you know, it's a favorite language for sure. And then a lot of other languages came from Python. Ruby, like I said before, Lua, a lot of other languages as well. Okay, or we digress. So let's get back to this. So we did this maximum function. It was pretty straightforward. And you can see that you can take this. If I want to, I've defined my maximum function to take values like this. But what if, and again, if I hover over max, you can see that it says this function takes 3 int arguments and returns the highest value. And it says that value 1 is an int, value 2 is an int, value 3 is an int, you know, kind of thing. But what if, even though I said that in my doc string, I said that here, value 1, value 2, value 3. What if I want to send in something else? Does it care? So if I say, well, I want to use max again, I want to do all this again, and again, I'm just adding more. And instead of 10, let's make it like 10.7 and 11.345 and 5.1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so kind of a longer thing. What does it do now? Maximum value of, we'll say, of a float, and we'll say maximum value of an int. Okay, so kind of both. And if I was to do this now, you can see that we're good, right? It'll handle ints and floats, and it doesn't care, right? Because by default, when you send parameters into a function, the function doesn't know what the parameter values are. It doesn't know, right? It's not like you define a type as an example, right? You don't sit there and say, well, you know, the parameter for maximum must be, you know, integers. No, and that's why, you know, you can certainly say that this is the case if you need to make them that, but a lot of times this doc string is good enough. A lot of times, right? So, because if you notice, like, just, you know, just works, right? Whether it's a float or an int, doesn't matter. And it truncates it. Notice how it truncated it to the, you know, kind of to the lowest one, right? So it says like, okay, well, here's like 0.7 and whatever. and then what it came down to. Now, one thing is, and this is what we're going to get to. Sure, we can reinvent the wheel. We can make our own maximum functions and so on. But a lot of times, what we can do. Oh, by the way, maximum will work with strings as well. I forgot to tell you this. But we have to make it work with strings. We have to say, okay, if max is a string, right, then do this. If max is a int, do this. If max is a float, do this. But why bother when the max built-in function does a lot of it for us? So if I did that, let's go back out here and stuff. So what I'll do is instead is I'll do this. I'll just comment this out. So again, hashtag. And then if I go down here and try it again, you can see that it still works, right? The same as before, even though I commented it out, right? Because max, the 3 characters, max, is a thing. It actually does work like this. And max also takes in string values, not just ints and floats. So example, let's grab these last lines again. We'll put in some strings in here. So we'll say Toronto, Mississauga, and Oshawa. Why not? My buddy's in Oshawa. Okay, Toronto, Mississauga, Oshawa. Which one is the maximum of a string, right? And let's see how that works. So maximum is Toronto. How did it figure that out? Alphabetical order, where T is 20, I believe, and MNOPQRST, yeah, is way earlier than that. So, and MNO would be actually a greater value than M, but Toronto being the greatest value. Greatest value for us too. All right, so it kind of does that nice and easy. It does it all, right? So max is actually a really interesting function, and so is min. And we use min max functions for data science, minimum, maximum. It's built in, and it gives us a lot of utility. Things we can do with it are really cool. So that's the built-in functions we were going to use. Oh yeah, now the fun part, random number generation. By the way, guys, I have to tell you a story. I know this is not the most exciting story, but for me it's exciting. When I was 10, when I was programming in assembly, first thing I wanted to do was I was saying to myself, hey, I really want to learn how to make a random number generator in assembly. And I can tell you that it was, wow, was it really hard. Like stupidly hard. But later on, when I started learning things like BASIC, because that was one of my second languages, I would say. BASIC was my second language, assembly was my first language. And then, as I started doing stuff like this, because basically once you know how to roll dice, I mean, in my mind I'm thinking Dungeons & Dragons. I can make my first Dungeons & Dragons game back, when I first learned how to program. I was really super excited about it because I was like, if the computer can generate random numbers, then you can generate random worlds, back in the day. And of course, we've done that now, not me, but we've done that. We've created random worlds with things like Minecraft and maybe some other games that they have randomly generated maps and randomly generated storylines and randomly generated everything. I think a lot of procedurally generated stuff, and I'm not just saying random, but also a procedure algorithm where you go through and process some data and maybe a pattern, sometimes noise, like Perlin noise that they use for things like Minecraft and so on. You can create whole worlds with simple random number generations. So I know, I'm sorry, I'm just telling you, it was just one of those things, Diego, where I'm thinking about generating random worlds from scratch. It's really this simple: import random, and then for every, I want to make a roll, I want to make a random range, right? And I'm going to go rand range, which is interesting. Rand range is very similar to the function we use in Unity, right? When we write games in Unity, random range, and then 1 to 7. We're not including 7. It's 1 to 7 minus 1, right? And notice we're using the end print, so it's printing numbers in the same line. End is equal to space. which is basically omitting the \n that's part of the regular print. Again, just a review from last week, right? So I want to do this random number generator thing, right? So I want to go back and do it. So I want to roll a d6, kind of thing. I want to roll, numbers, but I want to make it generic enough that I can roll whatever die I want, right? So I can specify the die range, 1 to 6, and then how many dice I want to roll, 3, 4, 5, or whatever. And then I wanted to create this function that rolls as many dice as I want, and then adds the result together, right, and spits out the number. Okay, random numbers. And I want also, this is my function I want to write here. By the way, I talked about earlier today in COMP301, I talked about some ways of getting better at programming, and because I've been asked that a bunch of times lately over the last couple of weeks by by people in our program. Tom, what would you do to get better at programming, kind of thing. And the one thing I always do is say to them, use it like a workout. Program, program at least 1 hour a day, if you can, right? Advantage roll the 2 to 20. I can do 2 to 20, no problem. This kind of thing, and it's program. Figure something you want to do, something you love to do, something you want to simulate with programming, and then write that code. Try and write it. Like, write this code that'll be a generic die roller, kind of thing. So let's try and do it. I want to make this random dice, or a dice result, let's say, and I'll make a new file for this. So we'll call this, random, kind of like dice, random dice, we'll call it. .py. Sure. We probably should separate it with an underscore, but whatever. And we'll make a new function called random dice. So the function will take in a minimum and a maximum value. So min, max, right? And then how many dice? It's kind of number of dice, or dice num. We'll say call it dice num, right? Number of dice. And what it's going to do, we're going to make a doc string, right? Okay, I'm not going to use this. I'm going to say that this function generates or rolls a number of dice. Let's use single quotes. Dice. Single quotes and double quotes is okay. Between min and max. A dice num of dice between min and max, right? And returns, prints the prints the results, prints each die rolled, and returns the result. That's what I want. Okay. Now you can make different functions. This is the one I want to make. Okay. So I want to make a die. So my die is going to be, or my base die is going to be between min and max. So I want to say base die is equal a number between min and max. That's what it's going to be. Okay. And again, you can use random. So we'll import random. Import random, right? Actually, let's see if we can do this. From random, import random range, right? Rand range, okay, as R. I love Python. All right, so I'm going to say that base die, then I'm gonna create this algorithm in a second. base die is equal to R of, and again, I want to go from min. So if I say 1 to 6, I want to say min to max plus 1, right? That's what I want to go with, right? So that's the base die. So that's going to give me a die roll every time, right? Base die is equal to this, okay? And I want to print the base die every single time. So print the base die result, right? Base die, right? Plus, sorry, comma, end is equal to this. So I don't want to print out the backslash n. Okay, so that's what it does. So print out the base die every single time. And that's my base case, guys. So basically, before I loop, I'm going to send in, and then dice num is going to be how many times I loop. So for, roll in, let's write this together now, right? So we're going to say for roll in range dice num, right? And we're going to move this one, base die, and print it out. So print out the base die. And what we want to do is we want to also have a result up here, right? Well, actually, yeah, so we'll say result is equal to 0. And then what we'll do is result plus equals to base die, right? So that's what will be the adding the result. And then what we'll do is, so we'll say print, better actually print this, yeah, that's pretty good. Print result is, and then we'll interpolate that. We'll say results. Okay. See if you guys can write it differently than me. So printing that result, and we're also going to return it. Return result. Phew. Right? Random dice. So it just takes the random dice, rolls. And now why do we care about the roll? For roll and dice, random dice? Well, we don't do anything with roll. Roll is actually lost. Sorry, it's not really accessed, so we just kind of sift through. And as long as, this is going to go happening, right? Roll is a number, right? Now, the way they wrote it in the book, it looks like this. Notice that roll is also not used for roll and range, right? But I'm not going to write it that way. I'm writing it slightly differently. So let's see if this works. So now here is this, and inside my main, I want to, let's do this, from random dice, import, I'm just using the same pattern so you guys can see it, import random dice, right? And let's just leave it like that. We're not going to make an alias for this one, right? And down in here at the bottom, I'm just adding more stuff to it. I'll say dice result is equal to random dice. And I need to put in a min, a max, a dice num. So it says this function rolls a dice num of dice between min and max, prints each die roll, and returns the result. All right, so let's do that. So min is 1, max is 6, right? And dice number, I'll say, I don't know, we'll say 3d6, and let's return that result. So let's just do it. Okay, so that's what that does. And then let's do Python main. Let's see if I get it. So it says, okay, 554, result is 14, maximum value of a string is Toronto. Isn't that interesting? So here's something that I wanted to ask you about, right? I mean, it kind of did it in a weird order, right? I mean, it says maximum value of int is 11, maximum of a float is 11.345, 554, result is 14, the maximum value of a string is Toronto, which is here. Because I, my friends, did not do this in the right order. All right. There we go. We'll try that again. And don't go crazy. Okay, there. 662 result is 14. 12 and 2, right? 165 result is 12. Okay, so that's pretty simple. Let's try other things. Instead of random dice being 163, right? We'll make it 164. Random dice, 164. So 4d6. Okay, so 4, 1, 4, 3. But I only want to keep. I want to keep the highest 3 dice. I want to keep the highest 3 dice, right? And I want to make it as an optional parameter, right? So if the result is not entered, then I'm going to say it's -1. That's how we're going to write the optional parameter, right? So let's go back to that random dice. There's other ways to do this too. So I'm going to take an optional parameter that says, do you want to keep the highest one, lowest one? What do you want to do? And there's a couple ways you can do this. I want to either keep the highest one, right? So I can roll advantage dice, just like Tiago was saying. So if I take 2d20, so a d20 and a d20, and I keep the highest one, not add them together, right? I can almost create a mode, if you will, right? A mode. And the default mode would be result, like a sum, okay? Let's try this out. So default mode, so there's different modes. Mode, right? That's another parameter that we're not using right now. And we got to think about how we can use this. So it's going to be a couple ways we can do it. We can use an enum, okay? We can use an enum, enumeration. We can use a string. So we can say, you know, result, like a sum, or keep highest one, keep lowest one, you know, kind of thing, right? So we can do that too. So let's do a string first. So we'll say the mode by default is sum, okay? All right, but there's going to be three different modes. Okay, so mode number 1 is sum. So we'll say if mode is equal to sum, then we're going to do this thing here, result, and the result is going to be equal to thing. Actually, results 0, it doesn't matter. So we're going to say this, we're going to move this to this. We're always going to have a result. And result is always going to be kind of restored. So this part though, right, this part we're going to tab in, and we're going to make this part the sum type, okay? That's if mode is equal to sum. Okay? Elif mode is equal to, we'll say keep highest one, KH1, which is kind of like what they do in Roll20, right? Then we'll say, we'll roll the range, right? Like this. We'll do the same kind of idea, and what we'll do is we'll refactor this after. Okay, so do the base die thing, right? So base die is equal to base die, right? The result is going to be kept inside of a list, right? Like a dice list, right? So we'll call this dice. Okay, so dice array. Okay. Again, result, dice will be used or not used. It's up to us, right? And what I'm going to do is I'm going to say that instead of base die, I'm going to say dice. And remember what I want to do. I want to add another dice to the list, right? So dice dot, and if you notice there's append, insert, and a bunch of other ones. So these are all the different things you can do. Dice, right? I want to append, so if I do dice dot append, so it's going to add a new die to the dice array, right? So dice append, and inside there an object, which is going to be our min, max plus 1. Okay? So a random number between you know, whatever the minimum was and the max, let's say 1 to 6, right? I'm appending these as new dice, and then what I want to do is I want to sort them. So dice is equal to sort sorted dice. Remember this from last week? Sorted. Okay. Sorted dice. And I want to do this dice stuff in a loop. So for roll in range dice num. Okay. A little bit different. So I'm going to say in this range of dice num, let's say for example 4 dice, append each random die to the list, right? So, you know, 4, 5, 6, whatever it's going to be. Then sort the list. Sort the list, right? And let's print that. For now, let's print that list out. So after we do this, still in the elif, right? Let's print that list out. So print. We'll say I want to print dice and see what it looks like. Okay. So let's start there for now, and then we'll come back to this because this can be complex. All right. And how do we do it? So let's try and go using it by going to, so by default its mode is sum. If I don't put a mode, and if I just use it the same way, then it'll skip this whole part and just do what we've already done. So let's try that out first. So main, still good, right? 6, 6, 1, 5, because you're adding them together. 6 and 6 is 12, and 5 is 17, 1 is 18. But I want the 3 highest, and I want to drop the lowest one, okay? So how do I do that? So this is where I can use a different dice result. I can say dice result is equal to random dice 1, 6, 4. And then this time, instead of mode is sum, notice that that's a default value. I can say keep highest 1. All right. So a different way of doing things. And let's see what that does. So it says 2, 3, 3, 5. So it sorts it in a numeric order. Okay. This would be nice. And remember what I can do here is I can sort it in this way, but is there a way of sorting it in a different order, right? So let's take a look at that. If I say sorted and I look at it, you can see that sorted says none and then reverse, right? So I can actually reverse it as a Boolean, right? Okay. So sorted does reverse. So if I did reverse, so go back to, again, random dice. So sorted dot comma, and I want reverse, right? And is true. Let's say I want to say true, which means this would just be true. So reverse, right? Boolean. Then what do I get now? An error. Expected 1 argument, got 2. I want to reverse sorted dice. Let's see how I do this. I forgot how to do it now. Python sorted reverse. Yeah. Reverse is optional if true. I want to see an example of reversing in descending order. Yeah, I was right. Reverse, comma, reverse equal to true. All right, so comma, reverse is equal to true. And if I did that, then you can see that I get 6521. 6521, I can drop the last one, right? By let's try that out. So I can say dice dot pop, and if I did that, I'm just going to see if that does that create a new array. Dice dot pop result is 16. Oh no, it pops everything. No, pop, and it pops the index. I believe it. You have to specify the index, which is 0, 1, 2. Pop 2. Let's try that. No. Index out of range. Let's try that again. So array pop Python. Again, see what I'm doing? I'm in my mind, I'm thinking I know what I want, right? And I'm searching for how to do it. I know what I want to do, right? So it says, okay, return languages pop3, return value, okay, is equal to the return value, pop3, print updated languages, run code. What does it give us to, what does it give us? And this little craziness, this is good. Python, Java, C++, and C, and it pops the third value, 0, 1, 2, 3. So I want to pop the last value. That was right, actually. 0, 1, 2, 3. Because there's 0, 1, 2, 3, 4. I want to pop the third one, the fourth value. Okay, that's what I thought I was going to do. Oh, I didn't do it right. 0, 1, 2. 0, 1, 2. And does it do that properly? Sorry guys, I'm just in my mind I'm calculating how it's going to work. Yeah, you have to return it, languages.pop. So return value is what I want. So what I want to say is dice is equal to dice.pop 0, 1, 2. I want to pop the third value, 3. 0.pipe3, return dice. Let's try this out. And we've got a value out of range. Why? Dice pop3, pop index out of range. Why? I should have exactly what I want. Oh, I'm popping it at the wrong time. And I'm doing the sorted at the wrong time. I want to do this. This is the problem with stuff like this. I want to do this in here, but I want to reverse true only after it's been after you go through the lists. That's why we have no 3 to do. So there we go. So 1164, the result is 12. So let's see if that works. 6 and 4 is 10, and 111 is 12, right? And then wait. Print dice. Dice append. Dice sorted. Dice. Reverse is true. For dice num, print dice 3. What? Let's print each of the dice first. So we'll do this too. We'll print each of the dice that I'm getting. So print dice. And we'll do this, we'll break it down into small things. We'll say die is equal to roll min max da da da. And we'll say that this is die, dice roll append die, and we'll print die with end is equal to like this. Okay, so we'll print it out, and then let's see what we get now. We get some really weird error, but I want to know what it is. Okay, so so the first one, the result is 7. That's this part. That is if mode is equal to sum. Mode is equal to kh1, keep highest 1. Then we roll, we have a die. 5, 6, 3, 3, 3, 1. And then we have 1 at the end. Why? Hold on a sec. Let's not do this for a second. Let's see what I get. 6, 6, 2, 1. Okay, so that does the printing. This does this. And then we'll say print. Sorry, I just want to make sure that I have good understanding what's happening here. Yes. Okay, so 6156, it's sorted 6651. I want to keep 6, 6, and 5 and drop 1. I just want to drop the last digit, right? That's what I really want to do. So, and then if I was to do I want to pop that dice off. Dice is equal to dice pop 3, and then I want to print dice. Again, let's see what happens when I pop that off and do it. 1. So it looks like I pop it. Oh, I see what's happened. so it's the other way around actually. So instead of reverse, I shouldn't reverse it at all. I should just pop off the first one. So if I said dice sorted dice, I don't reverse it, and then dice is equal to dice pop 3, I dice pop 0. And then what happens there when I do that? 2. So that's what happens. If I dice pop 3, then what do I get then? 1. So that's return. So that's not really what I want. Let's undo that. I think it's there's a remove. Let's see if there's a remove instead of a pop. Dice dot remove any. Okay, so I want to remove a value. Does this remove an index or does this remove a value? Okay, so remove last index here. Python remove last element from a list. It's dumb, I know. Pop 1, 2, 3, 4, but I want the list. Oh, I see. Yeah, list.pop pops the last element of the list, and then I'm left with list. That's what I want. I'm just overthinking it. So not this. Dice is equal to list.pop. Print dice. But instead of that, that's not what we did. Dice.pop. Print dice. Yay. Okay, so that's what I want. So this is the list, and this is what's being returned. So return results. So return dice. So result is equal to results is equal to dice. And what I want to do is the result doesn't matter, right? The result will return 1 die, 2 dice, whatever. But I want to get the result is equal to, I want to add all the dice together. So I think there's a way of summing it up. Sort, pop, copy, append, clear, count, extend. I'm going to create a sum. Sum of dice, if I'm not wrong. So result is equal to sum of dice, right? And then we'll say we'll print the result is print results. Again, we're going to remove some of this stuff in a second. I just want to make sure that this is correct. Result is done. 15. 6 and 5 is 11, and 4 is 15. 5, 3, 3. 8 and 3 is 11. So this is keep the lowest one, keep highest one. Make sense? Probably not, because I went crazy. But let's take a look at this together and see what I did. So there's 2 cases. Mode is sum. I do this. I just sum everything up, whatever I have, and I get all the dice added together. Example, I have a dragon that has 66. I roll 66. I add them all together. I get the result. Okay. I want to roll a character, and I'm allowed to drop the lowest one when I roll my my dice. So I keep the highest one, or highest. Keep the highest die. If as an example, keep highest. Okay, keep it KH. Keep highest. I keep the highest 3 as an example, right? So keep the highest 3. So it says, mode, and then actually what this should be is like drop lowest 1. That's what it should be. Drop lowest 1 is this. So instead of keep highest 1, drop lowest 1. Okay. So drop lowest 1 in my main, that should be this one. So drop lowest 1. Okay. And now I want to write another one. I want to make another function that keeps the highest one. So I'm only going to keep the highest one out of all the one. I can roll 20 of them, but I'm only going to keep the highest one, right? So that's the other way around. So drop lowest one, and then I'll say else I'll say LF actually. LF is the right way to go. LF mode is equal to keep highest one. So this is, the first one was drop lowest one. That's what I was really doing. Keep highest one is kind of the same as drop lowest one, except it's going to sort everything. So it's going to do the same thing, right? I'm going to still append to the dice. So I'm going to add all the things to the dice, sort them at the end, sorted dice, reverse equals to true, right? And then I'm going to drop everything except for the other dice. So let's just grab everything here. Equals. And so this does everything else, but now what I want to do is that other thing, which I was doing. Dice is equal to dice pop. Okay? And I don't need a sum, I just need to result is equal to dice. Actually, but that's just going to return the... No, I was right the first time. Sum. That's also good, because this is going to take the list of 1 and sum it up, which is going to be just it's going to convert it back into an int. Yes. And the reason why this is good is because if I want to keep the highest one, so I have 2d20 keep highest one. Let's try that out. So main and dice results is equal to random dice, and I go 1 to 20, and then in brackets keep highest one. Okay, so keep highest one. Let's see how that works, and you can see that I get a nice error. Okay, so that's what's happened here. So for roll and range, type string, object cannot be interpreted as an integer. Okay, let's see how that works. Square minimum random rate, random dice. Okay, so what does that mean? That is being done on line 13. So it says file home line 13 and random dice for roll and range dice num. Oh, duh. I used it wrong. That's awesome. So I meant 2d20 keep highest one. So 1, 20, 2 keep highest one. 1 to 20, 2 dice, keep highest one. There's advantage dice for you. All right, let's keep going to the next one. 10.9, trace back, file, result is equal to 120, line 45 and random dice, result is equal to sum of dice, type error, int object is not iterable. Okay, that's just dumb. I meant result is equal to dice 0. I'll be okay. That should do it. Let's see. Why? What? Okay, dice, print dice. Dice is on line 45. So this is where the error is. Dice, dice, pop. Okay, wait. Let's see what the dice result is. Maybe I don't have to do that anymore. Print dice. And we'll say result for now, just to satisfy requirements. Result is equal to dice. No, that's keep lowest one. 11.5 pop. Pop. And I want to get the first one. Well, I don't want to sort it reverse, that's all. So let's not sort reverse this time. We'll sort it, but we'll do the same thing. Reverse dice, dump, bump. 15. Yeah, okay, that makes sense. So that is what I wanted to do. Print dice, result is equal to dice. Don't need to do this twice. And that does everything I want, guys. Okay, so I can do advantage dice, 14. Keep lowest one, right, with the other one. Keep lowest one, keep highest one, right? It'll do what I want it to do. All right, so that's kind of like a longish function. Let me put this up on GitHub for you guys because there's a lot of stuff here. And again, I was hoping you were going to play around with me with this kind of stuff because I think it's kind of a neat thing. Again, I just talked about learnings, right? This is how I do it. I kind of think about something and I'm saying, hey, wouldn't it be cool if, and then I program it, right? So added custom dice roller function. Okay, so boom, and then push. So you guys have that up on GitHub now. And again, we can predify this because, you know, as an example, if I say something like, I want to roll 2d20, right? Roll 2d20 and then keep highest one, right? Kind of thing. Then instead of me rolling how I'm doing it right now I'm sending min max, right? Min max, and then dice num, right? If everything starts with 1 in my random dice, the random dice can't start at 5, right, as an example, then we really don't need min, do we? Right? I just need max. And min will always be 1, right? That's the first thing. So we can kind of eliminate min. And then if I did this and I coded it like as if it's a min, max, and dice num, if I made this a string, and so I decoded it, right? So I want to splice our string apart. So 2 is the number of dice. D is our a separator, if you will, right? Or a delimiter. 2D, and then however I want, what the dice size is, 26, 66, whatever it's going to be. It's more like D&D, right? Then I can take in a number, right, and then split it in half. So I can split according to a delimiter. So let's see how we can do that with Python. So we can say Python string split by character, right? Oh, this is awesome. So we can say that, okay, text split, I want to split by a separator, right? So the separator would be a D, right? So again, we can say comma separator, text split, and then if using comma followed by a space is a separator, comma followed by space, so I can say there's 2 strings, text, right? And let's see what we get if we were to do that. So if I was to try this on the this, sometimes what you want to do is try it here on the command line, right? So we're going to say something like, okay, so my string is, we'll call it dice, right? And that's equal to 2d20, right? So if I press dice, 2d20, right? And if I said dice.split as an example, and I want to look for a specific character D, then I get this. Split actually splits it off into 2 and 20, right? So it gives me an array that gives me exactly what I want, 2 and 20, right, by default, right? So if I pass in dice instead of min, max, and dice num, right, 2 is the dice num, 20 is the maximum, and min is already 1, always 1, then I can look for a different type of input for random dice, right? So this is where we're optimizing now. So we're going to just call this dice, right? And we're going to say exactly what we did down here. We're going to say that min, so first of all we're going to split. We're going to say that dice is equal to dice.split, and we're going to split with a D. So we're looking for a D for the dice, right? So 2d20, right? And we're going to say that the first one, the 0, right? The 0th die is going to be the number of dice, dice num. So dice num is equal to dice 0, right? Min is equal to 1. Max is equal to dice 1. And now we've retrofitted everything like this. Okay, does that make sense? Hopefully. So what this does is it will take a string now, right? 2d20, keep highest 1 kind of thing, right? Mode is keep highest 1. 2d20, 4d6, right? So let's see how that works. So instead of us doing it the way we want now, there's no errors in the code so far. I'm just looking at my result here. Save. And if I go to my main, we just have to retrofit these. So instead of this taking 3, right, 1d6, so 4 is 4d6. All we have to pass in is 4d6. All right, and then here, all we have to pass in is so again, this is drop lowest 1, right? So if I want to drop lowest 1, 4d6, drop lowest 1. So I'm only going to generate 3, the best 3 out of 46. Okay, 2d20, keep highest 1. So 2d20, keep highest 1. That's what that is advantage dice right there for you. Okay, let's see if this all works anyway. So Python, and we'll say main.py. Okay, so we got some errors. Let's figure this out. So it says that okay, so type string object cannot be interpreted as an integer. Okay, that is on line 18. So 18 on randomdice.py. Okay, right, because dice num, we have to convert all this. Right now, dice num is equal to, these are strings, and I want to convert them to int, right? So could I do this int, because they're strings, now it's converting this to int, and same thing with max, int, convert this to int. Remember, these are the stuff we got from last week. We did all this last week. We converted things to int, we converted this back to strings, and let's try this out now and see how it works. Yeah, right? So here we go. So 4d6 with the result is 10. 6 and 3 is 9 and 1 is 10, right? Or I add 4d6 together, 1, 2, 3, and 6 is 9 and 4 is 13. So I add them together, I drop the lowest one, or I keep the highest one. Okay, let's try it again. Add them all together, 3 times 18 and 5 is 23, right? Keep the highest 4, 5 and 3 is 8 and 2 is 10. Keep the highest 1, 16. There we go. One thing we can try and do is keep the lowest one, or drop the lowest one, right? Drop the lowest one was one thing. Drop lowest one. We can also do drop lowest one with, which is like keep highest one. But we can also try and do keep lowest one. So keep highest one. We can have another elif mode called keep lowest one, so disadvantage, right? So we always wanted the lower one. And that would be the sorted reverse order, right? So if it's keep lower one, it's the exact same thing. And again, notice that there's like a lot of duplication. We have a lot of room for here for optimization, because it's the same code over and over again, just with minor variations, right? So we can think about some of the things that are repeating and some of the things we can drop. So keep lowest one, if we're going to keep that as an option, keep lowest one, LF mode, keep lowest one. We do the same thing, add them all together. This is the same as this one. Sorted dice is reverse equal to true. Reverse is equal to true. Capital T for true for Python. And then we'll do the same thing. So now keep lowest one if I want to keep disadvantage dice. So again, if I'm going to go to main, here's another one. Dice results is equal to random dice. And I want to do 2d20, but I want to keep lowest one, not highest one. So I'm just telling the dice roller what to do. And now you can see that. So there's keep the highest one, 13, keep the lowest one, 6. And then, oh, I rolled a natural 20, but it's okay, I'm getting a 6 because I'm disadvantaged dice. And I can say that too. Instead of like, you know, kind of running what it says, I can kind of say advantage, keep highest one, keep lowest one. Especially if you can do other crazy stuff. Let's say, for example, I want to add in, 66 dragon breath. I can add them together as an example. But I can also do things like, instead of keep lowest one, I can say advantage and disadvantage. I can call these whatever I want, right? Or I can roll a bunch of dice, keep lowest one, keep highest one. But anyways, so the idea here with the functions, I wanted to make an extended version of the function dice and mode, right? So you can have two different things that is taken. Mode is a modifier for dice, so it does different things, right? And now can we see some synergy, some things that are the exact same every single time, right? That we can kind of, we don't care if it's what mode it's in, that we can start reducing. It's almost exactly the same, to be honest, right? The only one that's weird is this one, right? But that's only because we're adding to the result. So I can probably optimize this if I spend some time, because we still do some kind of for loop. Every one of them does a for loop to dice num. Every one of them, right? It's dice num, dice num. Base die here or die here, it's the same. We just call it different things, right? Base die, die, same thing. We're printing the base die. We're printing, we could print the base die here. We are printing the base die here. We append, here we don't. So depending on what it is, right? Instead of switching like this, if here, sum, or whatever, we can do our roll, and depending on the other way around, we can say if mode sum, then do this, if this, then do that, and then we have the same thing. We can have a little algorithm that's much tighter than the way this is written, and kind of doing the same thing. And we can switch out reverse. We'll do reverse is equal to true if, depending on one of these things, right? So we can have these switched out. So we can have a lot less code than this. This is a big maelstrom of bad code, all right? All right, I'm not sure if you followed along. Hopefully you did. Who followed along? Anyone follow along with me? In this insanity. Yay, we got one person. Diego. But the idea is that we wanted to talk about random numbers. And once we start talking about random numbers, when we talk data science, now going back on topic after this long digression, but we learned some stuff along the way about how to generate stuff, right? Once we learn how to do random numbers, we can start generating strings of numbers, or we can start creating a simulation, right? For example, a population. I want 6 million numbers, and I'm going to show you how you can do that here. So sometimes we want to reproduce. We want, randomness to be reproducible, because if you think about this, there is no real random, right? From a randomness perspective, I know if you were another language, you'd be lost. From a randomness perspective, it's just a sequence of numbers that it's pseudo-random. It's almost like, think about a big list of numbers. I have a random number seed, and that seed is going to generate the exact same list of numbers every single time. It's almost like I'm picking from a specific list that's pre-generated. All right, that's what's happening in Python and in other languages, right? I want to be able to reproduce it, and the way to do that is to call the seed specifically what I want to, right? So again, what we're looking at is probability. Once we start looking at machine learning, it's using probability. So imagine I want to show how often a die faces 1 to 6 occur with equal likelihood, right? And I want to simulate this 6 million times, right? So to do that, you can do this. You can say, I want to import random. I want to have frequency numbers, so variables for frequency. We start them off at 0, almost like a tally, right? It is a tally, actually. And then for roll in range, up to 6 million, notice the underscore, 6 underscore 000 underscore 000, 6 million, right? This actually is a thing. Then I can say that whatever the face is, right, is my random.random range from 1 to 6, not including 7, okay? That's what it does. So that's the first thing. So it randomly rolls 6 million times, okay? The next part is, if the face is equal to 1, then increase the frequency. If face is 2, 3, 4, whatever it is, tally up, increment the number that's appropriate for that particular thing, And then what we want to do is print it out. And by the way, this greater than 13, all it does is it right aligns all these numbers, right, according to this frequency. We want to right align it, and so face is also right aligned, so it looks nice the way it's been written. That's all it is, right aligning it 13 characters in, right? 4 characters in. That's what it's doing with this fancy way of doing things, right? And we're printing it out. So these are some possible results. So you can see that they have about an even number of possibilities, right? Because you don't know if you're going to get and then from a pseudorandom number perspective, you don't know which seed you're getting. It's also random, right? But what we can do is we can actually select a seed that we want to use in our random number, so we can reproduce our results if we're kind of trying to debug a problem when it comes to machine learning or data science. Okay, that's what we want to do. So we can use something called random.seed, and we can specify the seed that we want to use so it's always the same every single time. So we can just use random.seed, and we put a number in there, the same number, and that's how we can get reproducible results. So going back to this, if I say that my random.seed, right, and I can do this, I don't have to do it here, I can do it anywhere I want. I still have to import random though, okay? So what I do is in main, I can say that I want to import random, okay? And inside here, right, in my random dice, I can say that random.seed is equal to 40. Okay, it's just a number. Okay? And I want you to watch the results now. If I say random.seed 40, what does it do? So if I run it, then I'm getting the result that looks like this. So I get 4551, results 15. Okay, let's try it again. See if I can get it again. 4551, results 15. And look at the numbers. 6632, right? And then 75, and then 129. They're the exact same numbers every single time, guys. Why would I want this? It's not really random at all. It's the exact same set of numbers, because then I can test a set of values. If I want to do some kind of algorithm, if I want to apply neural network on something like that looks like this, for example, I'm rolling these dice 4d6 as an example. Well, I want to do 1,000 d6 or 10,000 d6 or whatever it's going to be, right? Then I want the same number so I can try my algorithm out to make sure that I can tweak the algorithm with the same group of numbers so I can see that the numbers that I would get are more accurate, or the numbers that I'm looking for. Reproducibility is what it's called. Okay. So that's random seed. Now, if you want to take away the random seed, just like it shows us here, so notice that it says random seed here, right? And random seed here, but I'm rolling a random range every single time, right? Random range, random range. If I was to change the random seed, so if I said random.seed, right? So let's say I said that from here on in, though, I want a random.seed, and I don't want a seed value. I don't know if I can do this. I think I can in Python. Yeah, so, okay, so take a look at the first part. So the first part, 4551, 15, 2336. See, 4551, but this is wrong. This is different. So the second part is wrong, so I can reset it back to the normal way of doing things. So I can say, well, I only want to reproduce the 4551. That result is going to be the same every single time, but the rest is going to be going back to normal. Okay. And again, I'd want that because maybe some of it I want to be random. This part down here is going to be random, but this part right here is going to be reproducible, right? So I want to be able to do the same number over and over again for 46. Maybe I'm going to feed this number into some other number when I do some kind of test, but the rest of them can all be random from here on in, kind of thing. So that's kind of an interesting way of dealing with issues. Okay, so I'm going to put this up on GitHub. So say completed random dice roller. Okay. So this, oh, not pull, Don't pull. Push. That's funny. All right, there we go. All right, let's go back to this one. So that's about reproducibility, and we're going to get more of this later on. So this talks about what the dice roll does, and you can see this is from the book. One thing that we've done so far is we return a single value, right? And I talked about this last time. Here's the a little snippet of code from the dice game that's like craps, where you roll 2 dice and try and get 7 or 11 as an example. Here I get 2 dice from 1 to 6, right? I generate two random rolls, or pseudo-random rolls. I take, instead of returning one at a time, I can return them both in something called a tuple or a tuple. Some people pronounce that different ways, right? When I do this, this is the function roll dice. When I call the roll dice, right, what I'm actually doing is packing a tuple together into something that's different. I'm packing it together, right? And a tuple or a tuple is immutable. It's like a little pair, if you will, right, in other languages. So when I've got a tuple, right, or a tuple, or whatever it is, I want to decouple it, or I want to unpack. And I have to have the same number of parameters that are going to receive the values from my tuple as when I put it into it. So for example, if I have a tuple of 2, it's a 2, right? So example, my return for this roll dice returns 2 values, right? Then when I uncouple it, I've got to split the value into 2 different values. That's another way I can do it with unpacking. So packing and unpacking. And we're going to be talking about packing and unpacking a lot more when it comes to data manipulation later on, right? Because this is kind of where it's all at, right? Does it make sense? So I want to pack and unpack. Packing means I create a set, all right, kind of like of numbers together, right? A set. And then when I want to unpack that set, right? And I want to kind of assign values. You can actually do it with the 46 kind of idea. So let's say, for an example, and this is where I can also use the in operator. This is interesting. So I can say that I can take kind of a value, and I can check to see if one of these two in a tuple, if the value is one of these 2 values. So for example, if I roll 2 dice and I add them together, and I said, okay, whatever the result is that result in the tuple? If it is, return true. If it's not, return false. That's an awesome way of doing things, and you can't do that almost in any other language, not like this. Okay. So how does it affect me with my little example? So little example. Well, when I return, right now I'm only returning 1 result, right, and I'm losing all the the dice. I don't care about all the dice that I'm returning, but actually what I can do is, if I take, let's do it for keep highest 1 for a second. So notice that keep highest 1, or I shall do it for 46. 46 is drop lowest 1, right? Drop lowest 1. Printing dice pop, right? Drops the lowest 1, right? So dice then is the result when I sum up the dice, right? Instead of getting a result that sums up the dice, what I can also do is I can say that die 1, die 2, die 3, right? Because there's only 3 dice left, because I popped 1 off, is equal to dice. That is also possible, right? So I take dice. In this case, example, I'm taking 4d6, drop lowest 1, right? Now this won't work every single time because I can put whatever numbers I want in there. My function doesn't stop me from putting in multiple values. I can put in 10d6, and this would fail, right? It has to be the same number, right, that I'm unpacking. Okay, so, and then if I wanted to print those values out, if I wanted to print out die 1, die 2, die 3, you know, kind of thing. I want to print those out. And let's see what I get if it doesn't error out on me. Yeah, so take a look at that. 6, 5, 4. That's what I get out. 6, 5, and 4. So even though I pack them, right? I pack them up, and they're inside of even a list, right? They're in a list, you know, 0, 1, 2, value 0, 1, 2. I can unpack them this way as another way of doing things in Python, which is unique. Not every language can do this kind of thing, which is why Python is loved by data scientists, because you can kind of pack things together, put them inside of a column, if you will, right? And I can unpack them inside their own individual values, really simply too. All right? Packing and unpacking. Okay, guys, that's all I wanted to cover today. We covered a bunch of stuff. Again, more about functions and how to use them. A little bit about doc strings and how they're important from a convention perspective. You know, kind of functions that are built in, min and max. We covered those two functions, as well as making some of our own functions and returning multiple values. You know, with something like a tuple. Packing and unpacking, you know, which is what we covered at the end. Any questions before we depart for the day? I know it was a lot. And one of the things that you're going to have on your assignment is this data manipulation stuff. You're going to load something in from the console. You're going to type some stuff in. You're going to return stuff out. You're going to push things off into a file. All this kind of stuff is going to be something that you're going to see that's going to come at you on Thursday. But it's nothing that you can't handle, nothing that we haven't seen before. Again, this is not super exciting stuff, but notice the majority of what we did today was non-object oriented. I know it's a lot to absorb, Rosalie. I really do know. And like I said, Python, at the beginning, easy to learn, hard to master, right? So we're going to keep on working on it. And the best way to learn Python is to do Python, right? So try doing that. Try making your own dice roller. You know, see if you can roll 5 dice together and put them together. You know, try different things out. Practice, you know, some small examples. And you know, you're gonna come to it. You're gonna see errors. Like I made a lot of errors here, and then I was able to go up online, look them up, try and figure out how to use the functionality, and put it together in something that was neat, you know, somewhat decent. At the end, any other comments or questions? All right, guys, thank you so much. I really do appreciate it. I'm gonna stop streaming now. And